All right, ladies and gentlemen, what I want to do now is I want to kind of go back to Newton's second law, and I want to take a look at that again. And then what we're going to do is we're going to start to apply it to some actual physical problems. I'm reluctant to give you any homework tonight. I think I'm going to wait until tomorrow to give you any homework because I'm still trying to finish up the grades for tomorrow. I'm pretty well caught up. There's a few more things that I have to grade. So I'm going to give you guys one more day's worth of break and then we're going to get back into the homework tomorrow. So let's go back and take a look at Newton's second law and see what it says again. And then I want to see if we can make some more sense out of it. Okay, so Newton's second law. What this is telling us is that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So in other words, what it's telling us is that for any object that accelerates, the greater the force or the greater the net force, the greater the acceleration. Um, and for any acceleration, um, if you have a certain fixed force, you're going to have less acceleration with more inertia. So in other words, heavy objects aren't going to accelerate as much as lighter objects with the same force applied. And it's given as sigma f equals ma, where the sigma f can mean one or more forces acting on an object. So I'm going to explain to you what I mean by that. I'm going to give you some really pretty straightforward examples today. And I'm also going to start to apply it to kinematics as well. So this is a new formula. So let's see if we can make some sense and work with this for a little bit. So let me go and get some examples here for you. And I'll need you to copy these down in your notebooks, please. And then I'm going to go ahead and try and solve them. Okay, now in this first example, it says find the force required to accelerate a 6 kilogram mass 5 meters per second squared. So let me show you how to do this. How you should be thinking about it. As always, we always want to write down our givens and unknowns. So make sure we know what we've got. So what's given? Mass is equal to 6 kilograms. The acceleration is 5 meters per second squared. And we are looking for the force. So we're going to write down our equation, sigma f equals ma. Now, there is only one force acting on this in our system, so I don't have to worry about two of them. So I'm just going to write down F is equal to 6 kilograms times the acceleration of 5 meters per second squared. So that means that my force is just going to equal 30. And we could write down kilograms meters per second squared, but all of that means newtons. So the force being applied to this box is 30 newtons. That's how easy they are. Now they do get more complicated, of course, because this is a college course. So be ready for that. Let's find out on this one. It says here, and please write this down. Pause the video if you need more time. Two forces act concurrently. Now that word concurrently means at the same time. Okay, you're going to see that quite often in this chapter. Whenever you see concurrently, that means at the same time. So two forces act concurrently on a 7 kilogram mass in the same direction. The forces are 10 newtons and 15 newtons. Find the acceleration of the mass. All right, this one's got a little bit more going on. Let's write down our givens. we have a mass. And we actually have two forces, so I don't know which one's which, so I'm just going to call this 1, and I'm going to call this 2. Call them opposite, call them A and B, I don't really care. So my force 1, I'm going to make is 15 newtons. Now I say I'm going to make is 15 newtons because if that F1 is positive 15 newtons, then F2 is going to be negative 10 newtons. Okay, so because they're going in opposite directions, you're going to have to make one negative. And let's see, force mass, and what's the unknown? Is my acceleration. Now, in order to solve this, we're going to write down sigma F equals ma. Now, I have two forces, so I'm going to expand this sigma F out to be F1 plus F2 equals ma. It's going to be pretty important later on in this unit that you actually write them like this, please. I know that it's very easy to just do in your head, but they're going to get a lot more complicated, and this is going to help you a lot. Trust me. So now I've got 15 newtons plus a negative 10 newtons is equal to 7 kilograms times A. Okay, so I've got 15 minus 10, which is 5 newtons, is equal to 7 kilograms times A. So now, I have to draw up and ran out of room, unfortunately. So sorry about this arrow here. So now I have to divide both sides by 7 kilograms. So A is going to equal 5 newtons over 7 kilograms. So A is going to equal 5 divided by 7. It's going to equal to 0.71 meters per second squared. 0.71 meters per second squared. Okay, so the 0.71 meters per second squared, where do the meters per second squared come? Remember, a newton is equal to a kilogram meter per second squared. This kilogram is going to cancel out that kilogram, leaving you with meters per second squared, which is your acceleration. I think in the next example, I'm going to start to apply this to kinematics. Oh, no, I'm not. I lied. It's the one after this. So it says here a 25 Newton force accelerates a mass 23 meters per second squared. Find the mass. Why don't you guys go ahead and try this one on your own. Please pause the video, and once you're done solving it, then take a look at my solution. Okay, coming back. Hopefully you tried this. Force is equal to 25 newtons. Acceleration is equal to 23 meters per second squared. And I'm looking for m. So we're going to do sigma f equals ma. I only have one force here, so it's just going to be 25 newtons is equal to m times 23 meters per second squared. So 25 divided by 23 is 1 and some change. 1.08 kilograms. So the mass is equal to 1.08 kilograms. Okay, that is how we do these. And let's see, you try this one. So again, go ahead and give this one a shot. It's just like the one before. So again, we do sigma F equals MA. So at 12 newtons is equal to M times 18 meters per second squared. So M is 12 newtons over 18 meters per second squared. So that makes my M 0.66, I believe. Just double check. 0.66 kilograms. Okay. All right, ladies and gentlemen, this is our next example, and what we're going to do now is I'm going to show you the new stuff with Newton's second law, and then I'm going to apply it to kinematics, which we've learned in the last chapter, so you can see how they tie together. So we have a 200 Newton force applied to a 10 kilogram mass, and we want to find the displacement after 20 seconds of applied force, and the mass starts from rest. So what we really need to do here is we need to determine the acceleration on the block so then we can find the displacement. And the way to find the acceleration is using Newton's second law. So let's start with our givens, as we do with all problems. And we see we have a mass of 10 kilograms. We also have a force, F1, of 200 newtons. And we see that there's a time of 20 seconds. And let's see, the mass starts from rest. And is that all that we have? It starts from rest, so that means my V naught is 0. Okay, that's everything that we have. What I'm looking for is my position. So I guess I could also put in x naught is equal to 0. And my unknown is going to be x. Now, even though that's what the question's asking for, I need some more information before I can get x. And in this case, it's going to be the acceleration. So that is what I need to find first before I can actually answer the question. So we're going to start off using sigma F, sum of the forces, is equal to ma. The force is 200 newtons, is equal to 10 kilograms times A. So A is going to equal 200 newtons divided by 10 kilograms. And therefore A is going to equal 20 meters per second squared. Now that we have acceleration, we can actually go ahead and now go after the displacement. And we're going to end up going back to our kinematics equations. And I have a time, so I'm kind of thinking that x is equal to x naught plus v naught t plus 1/2 at squared is the best choice. So I'm after x, my x naught is 0. My initial velocity is 0, so this whole term goes to 0. Plus 1/2, now the a is what we just solved, 20 meters per second squared. And then it's times time, which is, ooh, a lot of 20s here. I don't know why I did that. 20 seconds squared. So my x is going to equal, what is it, 400? Not 400, 4,000? 4,000. Let me check. 20 squared times 20 times 25. Yeah, it's 4,000. So this box is actually going to move 4,000 meters in that 20-second interval as long as the force is being applied to it. Okay, so that's how we would apply a kinematics equation to this. And so let's go ahead and move on to the next problem. And this one is going to actually use concurrent forces. So I'm just adding one more little piece to it. It says here a 50 Newton force is applied to a 6 kilogram mass directed towards the east. Concurrently, now remember, concurrently means at the same time, a 30 Newton force is applied to the west. Find the velocity after 10 seconds if the mass starts with an initial velocity of 12 meters per second towards the east. There's a lot going on in this problem, so we're definitely going to want to write down our givens and unknowns. So my F1 is 50 newtons. My F2 is negative 30 newtons. And the reason I'm making that negative is because this is positive. Let's see, find the velocity after 10 seconds. So my time is 10 seconds. Now let's see, what else do we have? We have to move this up. What else do we have? Okay, times 10 seconds. The mass starts with an initial velocity of 12 meters per second. So we have that. So my V naught is 12. So this thing's just moving along at 12 meters per second, and these forces are applied to it. And we're looking for final velocity. That's my unknown. That's my goal. Now, in order to find that, we really need to find the acceleration. So I'm going to, again, have to go to the sum of the forces, or Newton's second law, to find the acceleration. And then once I have that, then I can find the final velocity fairly easily. So let's start with sigma f equals ma. So I have F1 plus F2 equals ma. F1 is 50 newtons, and F2 is negative 30 newtons. So I have 50 newtons minus 30 newtons, and again, it's plus a negative, same thing. 6 kilograms times A. So 50 minus 30, that's 20 newtons, is equal to 6 kilograms times A. So now what I have to do is just divide both sides by 6. Then we have 20 divided by 6. It's 3.3 meters per second squared, and it's positive. Got to watch your signs on these. Okay, now that I have the acceleration, now I can go ahead and find the final velocity. And again, since I have time, I think I can just use v is equal to v naught plus at. The final velocity is what I'm after. My initial velocity is 12 meters per second, so it's already moving, plus the a, which is 3.33 meters per second squared times t. Oops, actually I shouldn't have said times t because I have it times 10 seconds. Sorry about that. So now I have 12 meters per second plus 33.3 meters per second. And that means my final velocity is going to be 45.3 meters per second. That would be the final velocity after these two forces are applied in opposite directions. Okay. And we've got one more to do, and then I'm going to show you something a little different. And then we're going to be pretty much done. So in this case, I have a 2,600 Newton braking force. Now I'm going to highlight this because this is going to be important to you. And it's applied to a 900 kilogram car that's traveling 22 meters per second. We want to find the stopping distance of the car. So again, this is a very real world problem, especially if you're in the automotive industry. These are things that you're going to want to know to make sure that the cars you're designing are safe. If the car doesn't stop, it's not going to be too safe, no matter how good it looks. So let's write down some givens. And my first given is 2,600 Newton braking force. Call that F1. Now it's important to remember that this is a negative. If we made this positive braking force, that would mean that the car is traveling backwards, or negative 22 meters per second. So we want to make that negative, and that's going to be important because that's going to tell us what direction our acceleration is. The mass is 900 kilograms. My initial velocity is 22 meters per second. And my final velocity, because it's braking, we know it's going to be 0 at the end. I'm looking for, and my x naught is 0. Of course, what I'm really looking for is x. But in order to find that, I'm going to need to find the a first. So just like the other ones, we're going to end up using sigma f equals ma. And my sigma f is going to be negative 2,600 newtons, the only force acting on it, 900 kilograms, and the a is what I'm after. Dividing both sides by 900. gives me negative 2.8 meters per second squared. Is equal to A. All right, now that we have our acceleration, we just have to find the stopping distance. Notice in this question, we don't have time. So we're kind of stuck with only one relationship that we have to use. And that relationship is going to be v squared is equal to v naught squared plus 2a x minus x naught. My final velocity was 0. Initial velocity, how fast we go, 22 meters per second. Plus 2, now what was my A? That's what we just calculated, negative 2.8. Times x minus 0. So 0 is equal to, is this 484 or something like that? It's 484. So this is going to equal 484 meters squared per second squared plus negative 5. Oops. Why did I just do that? No. Plus, what was it, 5.6? Times x. So I'm going to have to subtract 484 from both sides to solve this. So now I have negative 484 meters squared per second squared is equal to negative 5.6 meters per second squared times x. Notice how the negative, when we divide this by negative, is going to give us a positive, which is good because we want a forward displacement, not a backwards displacement. So it just kind of makes sense. So 9 something. 5.6. Oh, it's 86. It's going to give me about 86 meters. 6.4 meters. Okay, so there you go. This is how you would apply the Newton's second law to the kinematics. So what I want to do now is I want to show you a different type of force problem. Still using Newton's second law, but we have to do something different to it. So let me pull up this next example. I think I only have 2 more and then that's it. So let's try this next example. So this one's a little different, and I'll take a minute just to copy this down. So it's a 5 kilogram mass is being pulled by a 20 Newton force at a 30-degree angle. I want to find the horizontal acceleration. Now, what makes this a little different is that the full 20 newtons isn't causing it to accelerate across the floor. Some of it's actually lifting up on the box. So we want to find the portion that's actually going to be driving it horizontally. And in order to do that, we have to break it up into its components. That's a good thing we learned vectors before this, or we wouldn't be able to solve this problem. Almost like it was planned. Interesting. So let's go ahead and break this up into its 2 components. So I have fx and I have fy. Now, I really don't need to find fy because there's nothing going on in the vertical. In the future, we will have to find both of them, but for right now, we do not. So let's just go ahead and take a look at the fx. In order to find that, I'm going to end up using cosine, which is adjacent over hypotenuse. So let's write that down. Cosine theta is adjacent. You can skip this part if you know this. You probably do by now. Most of you anyways. Is equal to fx over 20 newtons. Okay, so now I have 20 newtons times cos 30 is equal to fx. And then what I need to do is just solve for fx. We're looking at 17 something, looks like. Find out. Fx is equal to, how much I think it's an fy. X is equal to 20 times cosine 30. I think it's going to be about 18-ish. I'm not sure. Oh, 17.32. Off a little bit. Okay, so this is really my applied force here. So when I write my givens and unknowns, my F, and we could call that X if you want, is 17.32 newtons. It's the only force going in the X and Y. So that's good. What else is given? Mass is 5 kilograms. We want to find the acceleration. So that's my unknown. So we're just going to do sigma F equals ma. So we have 17.32 newtons is equal to 5 kilograms times A. So A is going to equal 3 and some change. 3.4, I think. Check out, find out. 132 divided by 5. Yeah, 3.46 meters per second squared. And that's how you find a problem where you're being pulled at an angle. All right, I am going to ask that you copy this down and pause the video, and I want you to try this one on your own, and then I'll come back and show you how to solve it. Okay, hopefully you had enough time to solve it. If not, just pause it again, but I'm going to go over it right now. Let's see. So the first thing I want to do is I want to break this vector into its two components. I'm not worried about the y component. We haven't even talked about y yet, which we will next class. Let's get through this first. And let's see. So we're going to call this fx. And I am not going to go through how to solve fx again. You can look at the previous example if you're not sure. You guys should know this by now anyways. So it's just cosine of 40 times 60 newtons gives me 45.9 newtons. To the right. 45.9 newtons. Okay. So what I want to do now is I want to go ahead and write down my givens and unknowns. And then we're going to go ahead and see if we can get the acceleration. So let's write down our givens. And I have F1, you can call that F1x if you'd like, is 45.9 newtons. F2 is negative 10 newtons. Don't forget, if this is positive, this is negative because they're going in opposite directions. The mass is 42 kilograms. And I'm after just the horizontal acceleration, so that's what I don't know. So we're going to do sigma F equals ma, and I've got F1x plus F2 is equal to ma, and I've got 45.9 plus negative 10 is equal to mass, which is 42 kilograms, times A. And we have to resolve this first, collect like terms, however you want to say that. So that's going to give me 35.9 newtons is equal to 42 kilograms times 8. And I just want to divide both sides by 42 kilograms. And that means that A is going to be 35.9 divided by 42. So 35.9 divided by 42 is 0.85 meters per second squared. Okay, and that's it. That's how you do these. So I'm going to give you some homework over the weekend out of the textbook. So please make sure you do that. It'll be due Monday morning, I believe. And I hope you all have a great weekend. Don't forget, you also have a force vocabulary due on Monday as well. So take care, have a good weekend, and just get this done. It's not too terrible today. After today, though, it gets really interesting. So take care, all.